All right, we're gonna try this again. I just videotaped this entire section and it cut off like with the last example. Very frustrating, but it is what happens sometimes when you're doing this. Listen, we're gonna do logarithmic graphs next. We've gotten very good at doing graphs over the semester. We've now had several different examples, and it turns out that it works very similar to the other ones. As long as we just know the parent or the basic graph, we can go from there and get the rest of this knocked out. The functions they're going to start off asking us are the very basic stuff where it says log base 3 of x and log base 1/2 of x. Those are two of the most basic functions. Now keep in mind when we did exponentials the other day that it was a ski slope looking thing. It either went up like this or it went downhill like that. We said it would go uphill exponentially, meaning it's getting bigger and bigger if the base is bigger than 1. We said it's going downhill if the base is between 0 and 1. Same kind of thing affects it here with these bases. Since the base here is 3, this thing is going to be going uphill as we go, as we go. Well, let's look at the picture of this. If I decide to choose some x's and y's to plug in and check out like a normal graph, let's take some numbers. I'm going to choose -1, 0, 1, 2, 3, and 9. We'll just do those, and I'll explain why I'm choosing these numbers in just a moment. If you plug in 1/2 for the x, you get log base 3 of -1, and that's supposed to equal my y. And if I rewrite this in exponential form, it's saying 3 to what power gives you -1. And there is nothing that you can raise 3 to make it a negative. If you have a negative exponent, that doesn't make the base negative, that flips the fraction over. It doesn't make the problem negative. There's nothing you can put in place of that. That means that this does not exist. It's undefined. All right, so let's plug in that 0. You got log base 3 of 0 equals y. Let's rewrite in exponential form. That'd be 3 to the power equals 0. And you can't raise anything 3 to the power to make it equal 0. Your temptation might be to put a 0 there, but 3 to the 0 is 1, not 0. There's nothing that will go there either. This does not exist. What we're noticing is that for the function, the logarithmic function, 0 and less doesn't exist. That means when I go to draw the picture of this problem, there's going to be a horizontal asymptote at 0. And the graph will not exist over on the left side of that asymptote. It only exists on the right-hand side. The domain for this is going to be 0 to infinity. 0 with a parentheses. We'll show you why it's 0, not 1 in just a moment. Anyway, let's go and plug in these other numbers and find out what points are actually on the graph. If I plug in a 1 right there, that's log base 3 of 1 is supposed to equal y. That says 3 to what power gives me 1, so of course that would be 0. When I plug in a 1 for the x, I get a 0 for the y. If I plug in the next number, you get log base 3 of 2 is equal to y. That would be 3 to the y power gives me 2. Now, understand this. This exists, but I don't know what it is. We have a way of finding that out. We haven't studied that yet in this class, so I can't really explain to you other than the fact it's a decimal between 0 and 1. All right? We'll show you how you're supposed to find that out, but we just know that that right there is just going to be a decimal. I don't know what it is. It's between 0 and 1. All right? So that's why I'm choosing specific numbers so I can actually do it without a calculator. The next time you plug in 3 for the x, and you're trying to find the y, I'm sorry about that, you say 3 to the y is equal to 3 to what power? Well, of course, that's got to be a 1. When I plug in a 3, the y came out to be 1. If I plug in a 9, log base 3 of 9, that is saying 3 to the y power gives me 9, and of course that's got to be a 2, because 3 squared is 9. So these are specific points on the graph. 1, 0, 3, 2, or excuse me, 3, 1, 9, 2. You see it? These are points on the graph. Here's a couple of more points on the graph. If I plug in a 1/3 and a 1/9, let's plug those in and see what kind of y's come out from there. If I say log base 3 of 1/3 is supposed to equal y. That says 3 to the y is equal to 1/3. How do I flip a base over? I make the exponent negative. Y would be a negative 1 there. And the same thing if I plug in a 1/9 there. It's saying 3 to what power not only flips it over, but squares it. That would be a negative 2. So here's 2 more points on the graph. 1/3, negative 1. 1/9, negative 2. Do you see the picture? It's going to be like that reverse ski slope. It's going uphill because the base is bigger than 1. Okay? The one thing that you need to know anytime they ask you to sketch the graph of a logarithm is it always starts at the point 1, 0, just like the exponentials always started at 0, 1. Notice the x's and y's are swapped. That's because the exponential and logarithmic forms are inverses of each other. That's why we studied the inverse section just a moment ago. With this section is they're wanting to remind you what an inverse is, and then they're explaining to you that an exponential and a logarithm are inverses of each other. So when you sketch the graph of an exponential, it starts off at 0, 1. So the y-intercept is 1. You swap the x and the y for the logarithm, it starts at 1, 0, and you decide if it's going uphill or downhill, but the vertical asymptote doesn't change unless you add stuff to this. So now that we've seen the basics of this drawn, let's actually see if we can draw this picture and how quickly you're supposed to be able to do this. If I'm going to sketch the graph of this, notice nothing's adding to the x or adding to the function. I know that it's going to have a vertical asymptote at x equals 0. I know it's going to go through the point 0, 1, and because the base is between 0 and 1, I know it's going to hug here and be going downhill as it goes, and that's the picture. Now that's how you draw the base or the parent functions for these logarithmic functions, okay? Those are the 2 pictures we just sketched. They're actually going to show those to you in your PowerPoint. Hopefully you actually downloaded these PowerPoints, you're following along in your notes and taking notes off to the side just to remind yourself of certain things. But those are those 2 pictures that we just drew. Now what happens though if they do stuff to the function itself? They add numbers inside of the x's or outside the x's. Well, keep in mind, if I'm going to sketch the graph of this, I'm going to start off at 1, 0, and I'm going to have my asymptote at x equals 0. But because this thing has a plus 2 in there, I ask myself, what can I put in place of the x to make that 0? That'd be a negative 2. That moves the whole graph side to side, negative 2 places. That means now my vertical asymptote is at x equals negative 2. And this point is now there. However, a plus 1 takes the whole graph and slides it up 1. Now, sliding this vertical line up 1 doesn't change it at all. The only thing that moves this is going side to side. But this point does go up 1 unit. It's right there. And the last thing I had to decide, was it going uphill or was it going downhill? And since the base is bigger than 1, I know it's going to hug the asymptote and go up and through that point. There's the picture. The original picture would have looked like that. I simply moved it over to up 1 unit, and that's that second picture. Okay? Does that make sense? All right. So the next thing you ask yourself is, all right, how about this guy? This negative right here is going to mess with some of your minds. The first thing you do is ask yourself, how does this minus 1 change the graph? Well, what can you put in place of this x to make this 0? It turns out if you put a negative 1 there, those 2 negatives cancel out, makes it a positive 1 minus 1 is 0. So x is a negative 1. That means the graph moves left 1 unit. Okay? So let's look at the original problem. It was right here, and it goes through that point. But now I got to move the whole thing left 1 unit. So now the asymptote is here at x equals negative 1, and that point is on 0, 0. But how does a negative in front of the x affect a graph? It rotates it around the asymptote. So it's going to take this asymptote, treat it like a rotisserie chicken, like a little spigot going right through the middle of it, and rotate it around. So instead of being 1 unit that direction, it's now going to be 1 unit this direction. And since the picture was, the base was 2, it was bigger than 1, it would normally be going up in that direction, but now it's going to be going up in that direction. That's the picture of this function. And the third problem. Notice that this doesn't have anything added to the x in the middle. So I know that my vertical asymptote is going to stay right here on x equals 0. It's not going to move side to side any. I know the minus 2 on the outside is going to take the whole graph and drop it 2. It was originally right there, but now it's down 2 units. And the last thing I ask myself is the base between 0 and 1. That means this thing's going to be going downhill that direction. There's my picture. It's that simple. Okay? Your assignment for this section, for section 7.3, are these problems right here, page 542, 25 through 33 odd, and 47 through 69 odd.